I've been running this program here for the past few days, and so far it's working very well. The error is at 0.005, which is pretty good, but there is a problem. Well, not a big problem, just I only have 200 images. I have them reversed over here, but actually I have 100 images, but I augment them by reversing it, but that's not enough. You cannot train a good neural network on just one images. And down here, I'm trying to visualize the outputs. This is the outputs of inside the network. This is each of the convolutional layers. As you can see, they look. It breaks everything down. It's a little dark, but this is what it looks like inside each neuron inside the convolutional layers. It's a very small, relatively small network, not very deep, but it gets the job done really. I will add more layers later, but the problem of image augmentation is really a problem here, because without more images, the results are not very useful. I'm not really training on it. Later, I'm going to be training on MNIST, but without this, on just 100 images, that's just not enough to do anything. Okay, so here we're going to do image augmentation. Okay, so we have to figure out how to do it. Okay, here I'm using index map to D2 for scaling and convolution, but that's not really practical for doing image augmentation. So instead, I'm just going to make a function inside. I'm just copying all these functions right here. This flip 3D, shift 3D, and all that. I'm going to copy them inside the CUDA. It's not efficient, but it's the only way to make sure that you have good functions. Okay, copy and paste. Once again, we need that. Okay, first we have to figure out what exactly we're doing. Okay, index map, just copy each function. Well, let me start at the top. Tag index map flip 2D. Do I need to flip 2D or flip 3D? We have to decide. Okay, just CUDA neural array flip 2D. CUDA neural array flip 2D or flip 3D. I'm not quite sure if I should. Well, we have all three functions right here, so all three parameters right here, so it should be 3D. Flip 3D. The reason I said it to 2D over here because in the convolution part, in the convolution and scaling, all the parameters are the same size. All the outputs are the same size, so it's better to do it in 2D instead of if I do it in 3D, it's just gonna be a waste of memory. So that's why I do it 2D here. But here I'm going to do it in 2D. Not type in the next map. CUDA neural array result. CUDA neural array source. Okay, CUDA array result and source. I don't need that. If result source. Okay, we need to copy everything exactly. We're not index map create. Now we need to figure out exactly what we need to do here. Okay, no, that's nothing. We don't need that. If result array length. No, we have to figure out exactly what we're doing here. Yeah, it has to be the same size. Okay, I need to this if result source equals 0. No, source. Once I get the first one, the other one is just copy and paste. We have to figure out exactly what we did. First of all, we need a source, the source image, and a result image. Well, in this is a result array. Flip 3D. If result equals 0, source equals 0 is I need to know. I compare shape. We have shape. Okay, shape compare. No, shape compare. Yeah, CUDA shape compare. Okay, now we have to make sure that the shape of the two images are the same. Okay, CUDA shape compare and result.array shape Oh, that's easy enough. Okay, we're comparing the two shapes and source.array shape. Source. Ah, not source. Dot array shape. Okay, end value. Okay, tells it it's a pointer. If shape compare equals 0, that means if they're not the same shape, return 0. They have to be the same shape. Okay, here we're doing in 3 dimensions, so it's 8 by 8 by 8. Okay, if you're using a different video cards with more computes, you can do however many compute units your video card has. That's something you have to figure out in CUDA. Okay, result.array width. No, array shape. No, array shape dot shape width. Oh, shape width. Okay, that's for the X. Now the Y. You don't need this. I think I do. Yeah, do I need this? Let me just copy it down here, just to make sure everything everything lines up. Y and Z. Same as the IJK here. X, Y. Whoa. And Z. We have to be sure that we didn't miss anything. Okay, shape width, shape height, shape depth. Shape depth. Okay. Okay, everything lines up. Got 8 by 8 by 8. Now we're good. Kernel array flip 2D. No. Kernel array flip 2D. Copy and paste. Kernel array flip 2D. Okay. Just make sure the name's the same. Why does it matter if I don't have all the parameters? Okay, now we need to remember value source length. Oh, beside that we got X, Y, and Z. A, B, and C, not X, Y, and Z. Okay, length, and that's the parameters. Okay, so far we're good. Now for I, J, and K. Okay, remember we're copying this function right here, I, J, and K, but in 3D. I, J, and K. Okay, make sure you don't miss that one. We're just copying everything exactly, but put the corresponding values. Be very careful not to miss anything. Okay, now copy. Okay, remember that we might go overboard here, so make sure we're in bound. I, J, and K. Oh, wait. I forget. We can't just have length. It's width, height, and depth. Width, height, and depth. Make sure it's on side long. Okay. Oh, wait. Width, height, and depth. Everything lines up. Yep. ABC, width, height, depth. Okay, width, height, and depth. Okay, one step at a time. Okay, get rid of this. Okay, now let's copy the guts of this. Oh, this part's gonna be complicated. Okay, shape index. Now, this is gonna be complicated. Okay, we have to copy shape index. The entire function. Okay, wait. Now where is it? Shape 0, shape. What do I have? Keep shape. Okay, shape index. Oh wait, it's not here. Okay, let's just copy it from here. Where's shape index? I'm going to need multiple places, so I'm going to create a function for it. Add, subtract. Okay, flip to the global add for subtract. Okay, let's create a function, shape index. No, on device. Kernel shape index. Kernel shape get index, not type shape. XYZ width height depth. We have to copy the entire width, height, and depth. Because we need to make sure that we're in bounds. Okay, ABC width, height, depth. Doesn't matter. If shape inside, ooh, we have copy shape inside also. Okay, shape inside. Okay, if X, I'll just copy X, Y, not Y, and Z. We check if we're inside the index, and long depth. Why unsigned long? Oh, it's supposed to be unsigned long, but we recasting everything, so I don't know why we're doing that, but I said as unsigned long because it has to be positive, but here the program requires it to be the same type as the X and XYZ, which itself has to be signed because it can go negative. Not width, not height, not weight, height. Pronunciation, depth. Okay, this part's good. Okay, we're inside. CUDA invalid index. Yep, it's good. Okay, if width times height times z. That's the coordinate. Width times height times z. That gives us the which image we're inside, in which image we are. And then plus y plus width. Y times width gives you the row, and plus the x equals the actual column within the row. Okay, so far we're good. Kernel shape get index. No, let's call it device shape and index. Device shape and get index, because it's a device function. Okay, it's a device. We're in. Everything's good. If it's wrong, it will return a CUDA invalid index. Okay. We cannot return 0 because 0 is a valid coordinate. Kernel array flip 3D and device shape get index. No, not result. IJK 0. Wait a minute, is it inside? No, wait. Width, height, depth. Okay, we have to copy all of the values here. Well, most of them. Okay, unsigned long result index XY, and Z. I don't know why we'd ever need to use this Z part, but just in case, just keep it in. Okay, Z, copying everything as is. A, B, C, K, and K. Okay, device shape get index, copy, and paste. X, Y, Z. Okay, let's copy this, width, height, and depth. Whoa, depth. Okay, make sure we didn't miss anything. I'm sure I did, but hopefully it's nothing really too important. Source index, result index. Okay, source, now result dot result index equals source dot source index. Oh wait, we can't do that. We cannot do that. Okay, result dot with it. What the hell? Oh, we have to put a thing here. Okay, if source index not equals. Okay, there's a reason why I don't like using this thing, because it's relatively slow. I mean, it's fast because it's CUDA, but it's still relatively slow compared to using index maps. Okay, we have to do the calculations for each individual pixel, and that's just really slow. Else result index equals 0. Otherwise, you can get some weird result. Okay, that's just about it. X, Y, Z, I, J, K, and we're done. Box per grid. Oh wait, except for here. Of course, we're not done. Result source. Oh, what am I doing? Oh, A, B, C. Okay. I was wondering why this was here. I completely forgot. Result array data, source.array data. No, not source. Source.array data. Let's just move it down here just so I can see what I'm doing. Source.array data. Otherwise, we're going to get lost. A, B, C. Oh, wait. Just copy and paste this part right here. I don't feel like typing this. Okay. Whoa. Oh. Tab, 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 tab. Oy. Okay, tab. No. And comma, comma, no, and good. Okay, why does it do that? Whatever. ABC, source data ABC. Okay. Okay, that's the thing. If A equals 0, or if A equals 0, you do this, you flip. No, if A equals 1, you do this. If A equals 0, you just do this. That's the ternary operator, in case you don't know. Okay, so flip is done. Now the next one. Let us copy and paste everything. No, except for this part. I'll just copy and paste. We'll erase it. Okay, get rid of this. Right, that. Flip, and what's next? Flip to the shift to the shift. Let's just rename it. Shift. Why am I? Shift. Okay. Jeez, I must be shifting, but no. Oh, I have cap locks on. Shift 3D. Okay. Everything's the same except the names. I'm changing the names here just so I don't forget. Shift. Okay. Can't type. Shift 2D. Okay. Okay, making sure I didn't miss anything. Okay, let's just copy it. Index map copy, shift. Oh, that's simple enough. It's just addition. Make sure we're in the right place. Ah, crap. Okay. Z equals K plus C. We're just adding. Okay, make sure I didn't miss anything. XYZ source index. Okay, done. Shift 2D is done. Now, next. What is next? Shift zoom. Just going to do all of them. Okay, zoom 3D. Zoom 3D. Okay, what does zoom do? Double. Oh, zoom requires a double value. Okay. It's not that complicated, but whatever. No, double. 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 Double here. Double here and double here. Okay, zoom. All the parameters are the same. Okay, everything's the same. Just we just have to copy all this here. Okay, XC, YC. Ooh. Just make sure we get everything in the right place. Long X, Y, Z. XC, YC, ZC. Z center. Okay. Okay, first we calculate the center. ZC. Come on. ZC double. No, what is it doing? Width. Just copying everything exactly. Height and depth. Okay, now we have the center. Next. For IJK equals, just take everything and copy and paste. XYZ. Z. Z. C. No, K, not I. I'm making mistakes here. X ABC times ZC. ZC stands for Z center. IJK, everything's same. We're just doing calculations. XC, YC, ZC. Why is it outside? Whatever. Doesn't change anything. Okay, IJK, more than equal return. Okay, we're done. Next. Scale. Ooh, okay. This one's slightly more complicated. It's so complicated, I don't even sure we should do it. Yeah, it doesn't make any sense. This one, just get rid of this. We don't care. Oh, we have a 3D version. Rotate. Ooh, okay. This one's more complicated. Well, slightly. I'm gonna have to look some things up because all the functions I'm using here have to be modified. Okay, we're just going to do rotate. Scale is slightly more involved. So just not going to do that at all. There's just no point. Okay, rotate. Okay, we cannot do rotate 3D. I mean, we could, but it requires a bit more math, and I don't feel like doing that right now. Okay, we have copy pi. Step 1, copy pi from somewhere. Const auto CUDA pi equals. Okay, well, that's easy enough. Okay, rotate 2D, not 3D, 2D. I really don't feel like doing anything 3D. I mean, I could, but not right now. I have to copy and paste from somewhere else, and I don't feel like doing that. Okay, what else we need? CUDA index map, rotate 2D. Okay, copy and paste everything. Okay. Okay, should I use the Z? I'm going to be doing 3D later, so let's just keep everything. Even though we're not going to use the K, let's just keep it anyway. Okay. ZC. Oh, there's no C. Okay. XC, X sign. Okay, I'm going to need sign. Ooh. XC equals width, height. Okay, CUDA sign. Now I'm going to have to just copy from math. Oh, it's here. Type math. Where's that sign? Okay, copy all this here. Yeah. Okay, device. No. Double underscore device. CUDA sign. Okay. CUDA as this, so it doesn't really matter. Am I where I am? Okay, I'm still here. Okay, CUDA device. CUDA cos. Okay, copy and paste. CUDA pi. We have to convert from radians to angles, because I only know how to deal with angles. Okay. Oh, that will do it. CUDA sign, angle. Angle. Just change the ABC to just angle. No angle. Okay. I should think about doing a 3D rotation, but there's really no point. I mean, you wouldn't gain anything from it. Okay, CUDA sign. Shape index IJK. Okay, now copy this. Oh, we need XT. Whatever that is. Okay. XT, YT, ZT, X sign, source index, XY, Z. I'm going to use 0. Oh, wait. Do we need 0? Oh, we need 0. K. We need 0. K. Oh, we need 0. Let's replace this with, no, K. We don't need a Z, we just replace it with K. IJK. So it's a 2D rotation, but we still need the depth. So that's why we need to do this. Okay, IJK, which height, depth, source index, equal, everything's the same. And I think we're done. Oh, that wasn't so hard. Okay. Okay, let's just change the names. Rotate 2D. Rotate. Angle, double angle. No. Oh, I got it right. I thought I misspelled it. Rotate 2D. Okay, kernel array rotate 2D. Angle. Everything the same. Yep, we're done. Oh, that was too easy. Okay, and I'll export. Put this side by side, and so we can export. Okay, wowie. Shift 2D, flip 3D, kernel flip 3D. Whoa, whoa, am I missing something here? Kernel flip 3D, flip 3D, shift. Yeah, it's good. and divide. Okay. Global. No, not global. CUDA null array flip 2D. Let's copy and oh, I didn't delete anything, right? Okay, flip shift 3D. We have to specify that it's 3D, just so no one gets confused. Is it necessary? I'm not sure if it's really necessary. Because in index map it's very necessary, but the 3D part is not necessary. It's clear enough. It just makes everything. Not quite sure if you should include it. I'm confusing myself here. Just keep it. I don't like to keep it around because it makes the name kind of uglier. Whatever. Just clip it. Shift 2D. Zoom 3D. And rotate 2D. Oh wait, wrong. Rotate 2D. Okay, not missing anything. Okay, we're good. Now, kernels, the other export. Don't do that to me. Copy everything. Just one more set of functions. Okay, reset everything here. Okay. Just we'll clean up the code. Okay. I think we're done. Save everything and we build. Oh wait, no. I have to close this so I can rebuild. Hopefully we're not missing anything. Hopefully. Oh, we are missing something. Oh, apparently it doesn't like the fact that I'm defining CUDA as a constant expression. Maybe this will work. No, is it? Something about CUDA. It doesn't like the fact that I'm defining something as a constant expression here. Maybe it's not registering inside the device. Nope. Punishable loss of data. Something about it doesn't make sense. Oh, wait. Zoom to... Oh. Something it doesn't like. I mistyped something. Yeah, right here. It's zoom, not shift. Oh, other than that, it works. Oh, build. Was wondering what I did wrong here. And it turns out to be something stupid. Again. Okay, everything works. Now let's do some data augmentation. Okay, I had the function for data augmentation right here. Get augmented. It just copied from data set to directly in the source array. Now let's do some modification and see if I can get it to work here. Okay, first of all, we need some arrays. Source result augment 1. Okay, augment 2 and maybe augment 3. I'm just copy from one to the next. I'm gonna stack up several augmentations, one on top of the other. So next thing I need to decide in what order I need to make them. Let me check something. Okay, first of all, I need to create the augmented arrays here. Augment 1. There's a lot of stuff here I didn't explain at all, but I'll deal with it later. Augment 2 and augment 3. Okay, everything's initialized. Okay, first thing, we need a zoom Okay, CUDA no. I need to copy everything here. Oh, come on. Where am I? CUDA library. CUDA neural array zoom. I just copy them. Okay, CUDA. Am I in the right place? I got two windows open and they're on top of each other. Okay, zoom. Dataset. .I augment 1. And augment. Oh no. What am I doing? And augment 1. Okay, step 1, copy inside augment 1. What? Whoa, I'm in the right place. Of course, it's defined. Tells me it's undefined. Augment 1. And dataset.y. Parameters ABC. And that's it. Okay, now we need to set it to a random value. Okay, we need to decide what this should look like. There are lots of choices here. Random value. Rand. I don't like zoom. Zoom is kind of ugly. Just make it something else. Rotate. Rotate 2D. Augment. Rand. What should I call it? No, 40 degrees. 40 degrees. Rand and 40. Is it 3? No, 4. I'm trying. My keyboard has a light on it, but it doesn't work right. Okay, 20 minus random 40. So plus or minus 40 degrees. 40 degrees in one direction or the other. Why does it do that? Whatever. CUDA neural array create rotate. Okay, CUDA neural array. Why does it do that? Let me check something. Something's not right. I don't know why it's still complaining that this doesn't exist. It's undefined. It is defined. Okay, I just copy it. CUDA neural array flip 3D. Okay, it's got we augment 1, augment from augment 1 to augment 2, 1 to augment 2. Okay, so we have to define where it goes. What should that one be? Ran. It's ran and 2, so it's 0 or 1. Flip one way or the other horizontally. 0, 0. Flip 3D. Why is it complaining? I have no idea why it's complaining. Okay, next one, last one. Source image, augment 2. For augment 2 to source is flip 2D or shift. Let's just shift it. Okay, now shifting it, rand, and what, 20 minus rand, and it's still looking good, minus rand and 40. We're shifting it by 40 pixels. One way, by 20 pixels one way or the other. So a maximum shift of 40 pixels. It's gonna be visible, I think. Okay. So why is it? Get rid of that. Let's try rebuilding it. See if I'm gonna rebuild and check to see what the error is. Okay, I just discovered I made a huge mistake here. This right here, device shape get index, it's the complete opposite of what I needed to do. You're supposed to return 0 here. And I return something else. Oh my dear. That's completely wrong. Completely missed that. Took me a while to figure that one out. Okay. I'm gonna try again, see if it works now. Okay, finally it compiles correctly. Took a while to get it to work there. Okay, here's what I got here. This is what it looks like when the images are augmented. They are rotated by random values and then shifted by random values. And okay, so it's still not visible the way I want it. So let me show you a better way. Okay, we got it. This is just one of those things that takes a lot of tedious stuff. You can do all sorts of augmentation here. It's still complaining that the names are undefined, even though it's accepting them. So I really don't understand why it's doing that. But anyway, this is the original image. This is what it looks like when it's been augmented. Just flip it, rotate it, and well, that's it. Flip, rotate, and shift. And it's moved back and forth. This way, as the network learns, it makes sure to learn a different image each time. This is not very useful by itself, but if you have a very few, like a few hundred images, doing this will help the network learn faster, or at least learn better. There are different kind of augmentation we can do, but for now, just rotate, flip, and shift is, well, fairly good enough. It's not great, but you can learn to do all sorts of different different type of augmentation besides this. But for now, that's it. I might add something more here, but and of course I have to figure out why it's complaining that the names don't exist. Must be something with Visual Studio. But anyway, I'm just gonna let it train overnight, and maybe tomorrow night we'll see what happens. I'm just gonna leave it right now. That's data augmentation.